Alright guys, welcome to your study guide for Unit 9, Quiz 1. I'll go ahead and go through probably all the questions this time. I usually just do the odds, but this time I'll go through all of them. It's not that many. So number 1, so explain how you can tell if an equation represents an exponential function and write an example of an exponential equation. So you could tell if it's an exponential equation if the exponent is a variable. So, and usually it'll be x, but it could really be anything. So an example of that would be like y equals 5 to the x. Anytime x is in the power spot, then you've got an exponential function. Let's go ahead and take a look at the next one. All right, for number 2, we got to decide which one of these tables represent exponential function. The way that you do that is by dividing each y value by the one that comes immediately before it. So, for instance, 16 over 64 is about 0.25. And then 4 divided by 16 is also 0.25. And 1 divided by 4 is also 0.25. When these are all the same, that means it's exponential. All right, we'll repeat that for the other one here. We have 10 over 5 is 2. 15 over 10 is 1.5. Now those do not match. So I'll put a little equal sign with a cross through them. And therefore this is not exponential. Let's go ahead and take a look at one more. 5 over 1 is 5. 25 over 5 is 5. And 125 over 5 is 5. Oops. And so therefore that would be exponential. Alright guys, so for number 3, we are given a table of data and we want to turn it into an exponential function. So the first thing that we do is we rewrite the table. Supplying the missing numbers between the x values, 2 and 5. So between 2 and 5 we should have 3 and 4 also. We know that at 2 the y value is 7.5. And for 5, the y value is negative 117.2. But we don't know these ones, so I'll just put dashes there. Now we know that since this is an exponential table, in order for me to get from here to here, I would be multiplying by some unknown number. And to get from here to here, I'd be multiplying by some unknown number. And to get from here, same number again. Which means that if I take negative 7.5, the first y value, and I multiply it by b 3 times, it should give me the last y value, negative 117.2. And then from here, we're going to go ahead and just solve for b. So step 1 to do that is to divide. Use my calculator for that. You get 15.62, and it just kind of keeps going after that. Now, how far do you want to round? Well, the more numbers you include, the more accurate it'll be. I wouldn't stop short of maybe 3 numbers, at least go that far. But let's go ahead and continue now. The next thing to solve for b is I'm going to raise both sides to the power that is a reciprocal of the 3 there, which is 1/3. So I'm going to raise both sides to the 1/3 power, and that cancels out the 3. It won't always be 1/3 though, right? It just depends on what power you have. Since I had a 3, it was 1/3, but if it was a 4, it'd be 1/4, and so on. Now for this, you're going to use your calculator. Don't forget, it's not 15.6266 times a fourth. It's 15.6266 to the power of a fourth. So that is different. Make sure you don't get those things typed in wrong in your calculator. Now, if I do this, I end up with about 1.988. Now, this is fine if I were to round to the third number after the decimal. Let's go ahead and check out part C. On part C, we want to find, that's the A value. Now I want to find, I'm sorry, the B value. Now I want to find the A value. Whenever you have an exponential function, you want to find two values. You want to find the A value and the B value. We've already found the B value, so we're going to plug that in here. Now I want to find the A value. To do that, I need to plug in something for Y and X also. And we can do that by just picking any pair of numbers out of our table there. So I'm going to plug in 2 for X and negative 7.5 for Y. And I'll also plug in the B value that I got in step B. And I'll plug in 2 for X. All right, so now I'm going to square this. And I get 3.953. And then divide. And I get about negative 1.897. And so my final answer would be like this. Negative 1.897, and the B value was 1.988. Now, just so you guys know, it's possible that the answer you get on this test is multiple choice. The answer you get, you're going to want to pick the one that's closest to it. So let's say you had a multiple choice test, all right? They may not have this answer available, but they may have something really close to it. Like, for instance, they might have something like this, negative 1.9 times 2 to the x. Okay, that's really close. Negative 1.9 is really close to this, and 1.988 is really close to 2. So you just have to be prepared to understand that the answer you get, especially if you have any rounding going on in your problem, it may end up just being close and not exact, so you want to pick the one that is closest to it. All right, let's go ahead and move along to the next problem. All right, so number 4 is actually going to be pretty similar to the last one we just did. It's just a word problem version of it. So it says we invested $1,500 into an account that increases your investment exponentially. 10 years later, you have $5,000. Write an exponential function to model this scenario. So we're going to make a table. We're going to let the starting time be 0. And at the beginning, we have $1,500 in the bank. And then it says 10 years later, we have $5,000 in the bank. Okay? After that, you're going to solve this problem in very much the same way that we did the last one. So I'll go through this a little bit quicker just so we don't waste time. But from here on out to write the equation, it'll be the same. But the main thing is to get it set up. And so I'll restate that before I go any further. Your starting amount is going to go here with a 0 next to it. Your ending amount goes here with however many years or whatever it took to get there. But the rest of the steps are just like what we did in number 3. So I'll go ahead and do the rest of the problem at this point. All right, and so here's the first 2 steps to that, and I end up with b equals 1.28. So for part C, since we have the 0 value here, that's the starting amount, that's going to be our A value. So for part C, the answer is A equals 1,500. For part D, then our equation would look like that. All right, so Number 5 is another type of word problem. This is the one where instead of giving you 2 points, I give you a growth rate and a starting amount. So first thing that we want to do is we want to find our growth factor. This number here is our growth rate. To find your growth factor, you're going to do 100% added to 20%, which is 120, and then you're going to change it into a decimal, which is 1.2. You change it to a decimal by moving the decimal over twice. So that's how you change percentages into decimals, is by moving the percent or the decimal over. So my growth factor is 1.2. All right. For part B, they want us to write an exponential function to model this scenario using the variables x and y. So you're going to put your starting amount here. You're going to put your b value or your growth factor here. The power is x. The answer is y. So my starting amount was 50,000 birds. I'm just going to put 50. We're representing 50,000. And then we have 1.2 is the growth factor. That's what we got from part A. So for part C, we want to use our function to determine the number of birds in that region after 3 years. To get that, you would just plug in 3 for the x value and then use a calculator from there to get your answer. So when you're doing that on the calculator, you would get 86.4, and that would be 86.4 thousand birds, just so you guys know, it's since the numbers that we get are in the thousands. All right, so there is number 5. Take a look at 6. All right, so for part A here, for number 6, it tells us we have a disease is introduced into the region. Now the bird population is decreasing according to this function here. So part A is asking us to find the growth rate. Well, this number right here is my growth factor. Right? So if my growth factor, I'll just abbreviate that, GF is 0.75, that should be equal to 1 plus my growth rate. And I'll just put R here instead of growth GR. I'll just put R. And then we're going to go ahead and subtract here. And I end up with negative 0.25. As a percentage, that would be negative 25%. So here's my 2 answers here for the growth rate. All right, that's part A. Part B, what's the initial population? That would be the number in the very front there. So that would be 87, 87 birds. It didn't say if it was 87,000, or it doesn't tell us if it's in any kind of units, so I'll just say 87 for this. Part C, is this exponential growth or decay? Well, since the b value is less than 1, or another way of saying is since the growth rate is negative, this would be exponential decay. Okay? In other words, the problem is getting smaller over time. All right, so now we're ready to go ahead and graph some exponential functions. This is from lesson 9.2. So if you want to graph an exponential function, the first thing that you're going to do is you're going to add the a to the c to get your y-intercept. So my y-intercept would be 2 plus 3, which is 5. Next, we're going to find our horizontal asymptote, and that will always be y equals whatever this number is here. So in this case, it's 3. The next thing we got to do is we've got to determine our shape, and the way that you determine the shape is by looking at the b value and the a value. If your b value is less than 1 and your a value is positive, then you're going to look at a chart that I gave you guys back in lesson 8.2. I guess I can put it back up here for you guys again. To determine, you're going to look at this chart to determine what the shape will look like. Okay, so in this case, since b is less than 1 and a is positive, that's going to be this shape right here. So we're ready to graph this. My y-intercept was 5. My horizontal asymptote was 3. And my shape looks like this. There you go. That's part A. Let's go ahead and take a look at part B. Y-intercept is A plus C. There's no C. And when C is not there, it's 0. So my y-intercept is -3 plus 0, which is -3. The horizontal asymptote, once again, that's just the C value, and it's not there. There's no C value, so that would be 0 again. Now we do the shape. My B value this time is greater than 1, and my A value is negative. So with a B value that's greater than 1 and A value is negative, the shape would look like that. So I'm ready to graph this. My y-intercept is -3. Horizontal asymptote is 0. And the shape looks like that. All right, we got one more to do. Part C. On this problem, we are missing the A value. We have the B is 3 and the C is -2. When you're missing the A, it's a 1. So if I rewrite it like that, that might help. I guess I'll put the Y on the other side so it looks more like the other one. There we go. All right, my Y-intercept, once again, is the A added with the C. My horizontal asymptote is y equals whatever the C value is, which in this case is -2. The shape is based on the B value and the A. In this case, my B value is greater than 1, and my A value is positive. And when that happens, our shape looks like that. So let's put all that together. My y-intercept is -1. My horizontal asymptote is -2. And the shape with the top left shape. You guys have it. All right, so that's the stuff that'll be on our quiz. So hope that was helpful. We'll see you guys in class.